Okay, guys, welcome. I'm going to apologise now. The audio might be a little bit jumpy, and there's some. I've got a 6-year-old next to me, which won't leave my side. So, if there's any external noises, I'm going to apologise now. And also, I'm using a really horrible, crappy microphone because my wife is using my microphone to do her work downstairs. So, yeah, let's get started. So it's only going to be a 15-minute lesson, this, because really it's all based on knowledge that you already know. It's just putting it all together. So where are we? So we're going to look at three-phase motors, star and delta connection, and a star-delta connection, which is the third type which we're going to look at, which is important for assignment 1, question 4 and 5 on unit 63. So you're going to have a little bit of a look at motor theory. That's going to come in the form of some extra links that I provide to you with this video link. So you'll be able to go through and have a little bit of a recall on what three-phase is, three-phase motors are, how they work, basic motor theory, how that works, and then you're probably better off then coming back to this video, okay, after you've done that. So check for the links in the description below, then come back with this video. And then we're going to look at the way that star and delta start motors together, you know, which one we prefer over the other one, and actually is there a hybrid that we can work with, is there a best of both worlds? So star, it's also known as the series connected model. It usually has 4 wires. It's three phases and a neutral wire. In previous lessons that you may have done with this, I've seen this on some PowerPoints that have been handed over from lecturers that have worked at the college in the past, and they sometimes refer to that neutral wire as the ground wire, and that is wrong because we do have a separate ground wire for this. So neutral is literally a comparison between 0 volts and the voltage potential of the phase that you're at. So it should go between 0 and 230 volts, for instance. And that's the main way that we use star. We can go phase to phase as well. So if we have a little look at this diagram at the bottom, it's slightly cut off, but essentially if you're looking through the first phase here, the current flowing through the single phase would then go to the load. That would just be a single, and then the load would be connected between that phase and the neutral. There is another way of doing it, which gives you nearly double the voltage, gives you over 400 volts. And that is going from phase to phase. So you connect between that phase there and that phase there to make these two in parallel. So you'd end up with 415 or 475 volts, depending on the type that you're using. I've got some spelling mistakes on there. I do apologise. Line voltage and phase voltage do vary from each other. So each line voltage should be roughly the same, depending on how they're loaded and things. However, the line voltage and the phase voltage compared together should be totally different. The phase voltage, phase to phase voltage, will be much higher than the line voltage on its own. And because we only use one wire for single phase transmission, it means that we don't need it. Obviously, it's a low voltage because it's 230 volts. We don't need as much insulation around that as what we would do if it was delta connected or phase to phase. It means that we can send a lot more power with a lot less insulation required. So the initial setup for a network, if you were speccing out a warehouse, for instance, or you were wiring up a bank of lathes, you would probably use the star connection to get the power to the bank in the first place, because that's going to give you a much longer run for a cheaper wire to be used on that run, if that makes sense. It's coming out the right way. Because the line voltage and the phase voltages are different, the thing you've got to consider is, because this is a series model, where voltage drops around a series circuit are always different, but the current's always the same. It's the same in star connected things. So if we've got, if we're taking a voltage from a phase to a neutral to get the 240 volts, or we're taking a phase to phase to get the 415 plus, no matter what method we're using, we still limit it to the same amount of current. So the maximum current that will flow in the phase to neutral is the same current that will flow in the phase to phase. So use as well, it's used to start motors that don't require as much current, But there's also a way of doing it where we use that to specifically limit the current to a motor that would otherwise have a massive inrush current. We'll come to that later on. But they used to start low current motors or cause a low current to flow to a motor that would typically be high current. It also requires, we've said this before, it requires less insulation per phase, which means that we can make long runs with it quite cheap. Sort of a comparison of this would be my next door neighbour's just got a hot tub at the top of the garden, and it's cost nearly as much for the armoured cable to go under the ground as what it did for the actual hot tub itself. Whereas if I was to do this, I would probably bury it in some sort of PVC tubing and just use 10mm twin and earth film because I'm cheap like that. Okay. Right, so again, sorry for the spelling mistakes, guys. I'm knocking out like 6 or 7 of these a day, and it's yeah. So Delta's normally a 3-wire system. We do have a neutral with a Delta as well, but we don't normally go Delta to neutral. It's normally Delta to Delta with the neutral as like a current reference. It's only 3 wires, so only 3 wires are possible, and the line voltage is equal to the phase voltage. So the single line voltage, not that you would use a line voltage, but the phase-to-phase voltage and the line voltage will give you exactly the same value, which means that it's the opposite of the star in the way that the star connection keeps a constant current but a varying voltage. This keeps a constant voltage, so therefore the current must vary. Okay, so the line current, so that's the current running through one phase, is root 3 times by the phase current. So it's literally root 3 times by the phase current. And yeah, we've got some calculations there for you. So there's some uses for Delta. It does, again, I apologise for these spelling mistakes, guys. It does use high voltage, which means that it needs higher rated insulation. So it's not really economical to send voltages over large distances. So this would normally Delta connections would normally be used to send power maybe from one bank to another in the same factory. You certainly wouldn't send it from site to site or from city to city. And they're often used for high torque starting of motors because it can provide a large current. Because the current's not fixed, like it is with the Star, it can provide a large current, which can be a disadvantage to quite a lot of motors. But we'll have a look at that in a second. So, what can we do then? Well, what we normally do is we use a hybrid of Star and Delta. We don't normally use a Star system or a Delta system to start a motor. We use a hybrid of the two. So what we normally do is, because when you start a motor you get a massive inrush current, what you would do then is you would try and start it with a Star system, which will limit the current, so therefore the big inrush current that comes in won't be allowed to be drawn from the supply. And then once the motor's built up some speed, it's got up to about 80% of its full load. I don't know what I'm saying, but it's very funny. It's about 80% of its full load. That's when we then switch over to the Delta. So we've got the Star running here, and then we switch that over to the Delta, turn the Star off, and we run with a constant voltage, varying current. So as the load increases, the current can increase, but the speed will stay the same. So that's really why we use a Star-Delta combo. We would very rarely use a Star or a Delta to start a motor on its own unless it was very specific circumstances. Normally you would go and buy one of these things in a box, Star Delta motor starter. They literally come in a usually IP67, IP68 boxes with the glands in, and you would just glance straight into them, wire your motor up as you would go now, and away you go. Yeah, just a quick sort of run over of why this is really important. I know we've just mentioned quite a lot of points there, but it does Star Delta voltage motor starter does reduce the inrush current that goes in, and in fact around about a third of the inrush current is present compared to if you use the Delta connection. So the inrush current doesn't really, it gets the motor spinning faster, but it's disproportionate to the amount that the motor's going to spin. So yeah, it might make the motor spin up to speed twice as fast, but it'll use 6 times as much current, which obviously if you multiply that by 50 banks of lathes, you know, stopping and starting 100 times a day, you know, 5 days a week, 50 weeks a year, that inrush current will start to add up. So by using a star delta configuration to start the motor, you're reducing that inrush current, but you're also getting the full advantage of having the full torque and full variable current at full speed. Now, I've put the calculations and all the information that I've put here is mainly from this website and my own knowledge, but the calculations, things I've referred to on this website, and there's also some information on here to do with star and delta motor windings themselves. Okay, so I'll put some more information there, but this is just a little bit to get you through question 5, which references the star delta motor starting.